everyone, it's Justin again. In this lesson, we're going to be continuing our exploration of proofs, this time with triangles. As always, you'll want to have your property review activity on hand, and you may want to flip to section 5 specifically, since those are your triangle properties and theorems. By the end of this lesson, you will be able to complete triangle congruence proofs. First, we'll walk through planning triangle congruence proofs. Next, we'll create a flowchart proof. And finally, we'll create a 2-column proof. Here's our very first triangle proof. It says, given that L bisects segment TA, segment TE is perpendicular to segment LT, and segment MA is perpendicular to segment AL, prove that triangle MAL is congruent to triangle ETL. We also have a picture here with two triangles that have one shared vertex. I can always start by annotating my picture. What can I fill into my picture based on my given information? I can fill in that angle MAL is a right angle, since MA is perpendicular to AL. And I could do the same for angle ETL. Since they're both right angles, I know they're congruent, so I'll make those the same color to show that. I can also fill in that segment AL is congruent to segment TL, because L bisects the full segment TA. That's all I have for right now. Let's think about what this proof might look like before we start on it. My goal is to prove that I have two congruent triangles, MAL and ETL. There are only 5 ways for me to prove that two triangles are congruent. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. That's it. All of the triangle congruence theorems require 3 congruences. How many congruences do I have so far just for my given information? I have one side and one angle, so I need one more congruence. Can you tell from my picture what the last congruence is going to be? Remember, we can't rely just on the scale of the picture. We have to be able to back up our statement with a property, definition, or theorem. I don't know anything about the length of my other sides of these triangles, so this is going to have to be another angle congruence. That gives me 2 options. We either have to be able to prove that angle M is congruent to angle E, or angle TLE is congruent to angle ALM. Which congruence do you think I know from my picture? I know that angle TLE is congruent to angle ALM. Let's add that into the picture. But how do I know that these angles are congruent? It's because they're vertical angles. Take a look at our picture now. Which triangle congruence theorem will I use for this proof? I have 2 angles and a side. So that makes it easy to narrow down to either angle side angle or angle angle side. We'll be using angle side angle since our side congruence is included between the 2 congruent angles. You've been working with proofs for a little while now, so I'm confident that you can make your own flowchart for this proof. Instead of giving you a full flowchart to work with, let's do a quick summary. We know that eventually we're going to prove these triangles are congruent using the angle side angle congruence theorem. One of our angle congruences came from the perpendicular segments that we were given. The side congruence came from the segment bisector that we were given. And the second angle congruence came from vertical angles. So pause the video here and write your own flowchart proof for this problem. Here's how I chose to organize my flowchart proof. Yours may look a little bit different, and that might be okay. It is possible to do it in as little as 8 steps. But if you had 9 or 10, that should still be fine. What's most important is that you should have 3 branches, one for each of the congruences that we need leading into the final statement that the triangles are congruent by ASA. In the left branch, I put my side congruence, starting with L bisects TA. The reason here is just given. And from there, I could say that TL is congruent to AL because of the segment bisector definition. When working with triangles, it can be really helpful to code your congruences to help you keep track of them. I used orange dashes for my side congruence and have also labeled this final statement with an S to show that it is my side congruence. In the middle branch, I put my vertical angle congruence. My first bubble says angles TLE and ALM are vertical angles because of the vertical angle definition. This then lets me say that angle TLE is congruent to angle ALM because of the vertical angle theorem. I've coded this branch in blue dashes and dots and labeled the second statement with an A to show that it gives me an angle congruence. Lastly, in the right branch, I put my right angle congruence. I combined TE is perpendicular to LT and MA is perpendicular to AL into one bubble here. Sometimes combining things makes sense if they have the same reason and they lead to the same place in our flowchart. Here, both of these were given, and they both lead to the fact that angle T and angle A are right angles because of the perpendicular definition. We do need a third bubble in this branch to say that angle T is congruent to angle A. The reason for this is that all right angles are congruent postulate. I coded this branch in solid red, and I've labeled the last bubble with an A to show that it gives me an angle congruence. All three of these branches lead to my final statement that triangle MAL is congruent to triangle ETL by ASA. I could write this congruence statement in many ways, but we were told to prove this particular congruence statement, so we want to make sure it matches our problem. Now, this is how I chose to organize my flowchart, but it's not the only correct way to do it. You can always just check your logic and make sure that it matches mine, even if it's formatted differently. But I'll also show you a few alternatives. Your branches might be in a different order than mine, and that's okay. Or maybe you didn't combine statements for the right angles congruence. Or maybe you organized your flowchart horizontally instead of vertically. Once you're confident that your logic is correct, even if your flowchart is not identical to mine, we can move on to the two-column proof. As always, I'm going to number my statements and make them easier to talk about. Each of my three branches here are independent of each other, which gives me a lot of potential orders I can use for my two-column proof. However, to make your proof as clear as possible, it can help to keep each branch together in your two-column proof. By keeping each branch together, you're finishing your thoughts about one congruence before moving on to another, without having to bounce back and forth between them. For example, this order would be valid, and there'd be nothing wrong with it. However, this one would be much simpler and more clear, because each of my branches stays together. I think I'll use this order for my two-column proof so that it goes in order with an angle first, then the side, and then the second angle. If you'd like to use a different one, that is okay as long as it's in a logical order. Pause the video here to write out your two-column proof now. Using that order that I picked before, here is my final answer as a two-column proof. And you can see here how each of my original branches from my flowchart stayed together. Do you notice how, because of the way I numbered my flowchart, my two-column proof is numbered all out of order? If this happens, just renumber your statements so that your proof starts at number 1 and goes in order from there. Now you can complete triangle congruence proofs. Here are some tips that we tried in this lesson that you may find helpful to use moving forward. First, use the 5 congruence theorems as a reference to help you narrow down the remaining congruence statements that you need to determine. Next, code the branches or bubbles in your flowchart with different colors or patterns for each of your 3 congruences. Finally, chunk your two-column proof so that all of the steps for each congruence statement stay together. See you next time.